Hello everyone. For this lesson, I'm going to show you how to draw the resultant vector if you're given two vectors with an angle between them. Now in this question you have here, you're given two vectors with an angle between them, and please do not assume that the original question is drawn to scale unless it's specifically stated. Otherwise, do not assume that. Now first, you have to choose an appropriate scale. Now there's no specific way to tell you how to choose an appropriate scale. You just have to go by trial and error, as I'm showing you right now. 1:1, that means 1 cm represent 1 Newton. It's not possible because I cannot draw 4,200 centimeters here. So now I'm going by elimination. So I arrive at 1:1,000, and I realize that my longest length is 4.2 cm. So I decided to extend the length, and so I chose 1:500. So 1 cm represents 500 newtons. Will this work? I'm not sure. And that's why it's very important to draw using 2B pencil with soft eraser. So right now, I'm able to represent 3,400 newtons with 6.8 centimeters and 4,200 newtons with 8.4 cm. I now first draw the vector to represent the 3,400 newtons first, and that's a 6.8 cm. And if you look carefully, I actually try to identify, I draw a longer line first and mark out 6.8 centimeters. I don't draw exactly 6.8. I draw a longer line and mark out 6.8 centimeters. And on this line, I make sure that I represent the line with 6.8 centimeters and 3,400 newtons, with the 6.8 centimeters represented in bracket, so that I know which representation I'm looking at. And next, I need to mark out the 70-degree angle between 3,400 newtons and the 6,800 newtons. Sorry, 4,200 newtons. Also, look at how I draw the vector 4,200 newtons. I'm going to extend a long line, which is more than 8.4 cm, and then I will mark out 8.4 centimeters. Having extra lines, alright, you can always erase it later. Okay, but if you're having too short a line, you're going to extend it inaccurately later, so might as well draw a longer line. So right now, I already have two vectors drawn on this diagram, and next, what I need to do is to complete the parallelogram. I need to complete the parallelogram to locate my resultant vector. Okay, I'll just mark out the 70-degree angle first. Right, you recall back in primary school how you draw the parallelogram? Okay, align it with the set square and the ruler. Also, you notice when it shifted a little bit, I repeat the whole process all over again. Right now, I got a parallel side for the 4,200 newtons. And watch how I draw the dotted line. I extend it until it's out of the paper. As I said just now, if it's too long, never mind. If it's too short, you're going to have a problem. Now I'm trying to locate the parallel side for the 3,400 newtons. So the resultant force will be taken from the diagonal, and it has to be the vector that lies in between 3,400 newtons and 4,200 newtons. I emphasize again, the vector has to lie in between 3,400 newtons and the 4,200 newtons, in between there. And also note how I draw the vector. I represent the resultant vector with a double arrow, and in this case it's actually the resultant force. And to complete my answer, I have to measure the length of the resultant vector in centimeters first, because I already got a scale, and the scale I've chosen is 1 cm represent 500 newtons. So I have to measure the length first, which I got is 12.4 centimeters, and I'll take 12.4 times 500. That will give me the resultant force for this question. And finally, what is unique now is that the direction of the vector is not your usual north, south, east, west kind of direction, or front, back, left, right, up, down. This direction is taken with reference to one of the vectors. And in this case, I chose 3,400 newtons. You can also choose 4,200 newtons if you like. But in this case, I chose the direction to be the angle between 3,400 newtons and 6,200 newtons, the resultant vector. So for vector resolution, the direction refers to the angle between one of the components and the resultant vector.